Hello, everyone, and welcome to another episode of Space in Africa's webinar series that is titled Utilizing Digitalisation for Digital and Sustainability Transformation. The webinar is co-organized by Space in Africa and Planet. Planet is a leading provider of daily high-resolution satellite data that helps businesses, governments, and also researchers to understand the world and make informed decisions. My name is Mustafa Ideraoumi, a senior analyst at Space in Africa, and I'll be your host today. So over the next 1 hour, we'll be discussing how satellite imagery can drive sustainability efforts in Africa. And specifically, our focus will be to demonstrate how EU data can facilitate digitization and sustainability in Africa across 3 thematic areas. The first one is precision agriculture and its link to enhanced food security in Africa. The second one is urban planning for population management and municipal operations, while the third one would focus on will be disaster management and mitigation strategies. So now let me introduce our speakers for today. First, I have Annette Elting. She's the Senior Account and Partner Executive for Europe, Middle East, and Africa at Planet. And I also have Yegon Gerald. He's the General Sales Lead for Africa at Planet. So both speakers are adept at helping African organizations and companies alike to leverage EU data for better decision-making and outcomes. But before we begin, let me give a quick rundown of today's proceeding. So first off, our speakers will take turns to demonstrate how EU data and solutions have been aiding sustainability initiatives within the 3 thematic areas that I mentioned earlier. Then afterwards, we're going to take some questions during the Q&A segment. But before we dive in, I would like to say a very big thank you to everyone that has joined us today. Thank you for being part of this wonderful program once again. And if you have any questions or comments, please kindly drop it in the Q&A box, and we will ensure that we take as much as time will permit during the Q&A section. And with that overview, let me hand it over to Annette to start us off. Annette, if you will.
Yeah, so welcome to our webinar about how Earth observation data can be used for digital and sustainability transformation. And first of all, I also would like to thank the Space in Africa team to invite us and also organizing this webinar. And as I still see that people are coming into the webinar, I will I will please to announce the full Planet Africa team. So first of all, we have Jerry Maina Avanda. She's our Director of Business Development. Then we have Gerald Yegon. He's my co-presenter for today and is working as a regional sales lead for Africa. Then David Aal, he's working closely with Jerry as a business development associate. And my name again is Annette Elting, and I'm responsible for our channel partners in Africa. Our business development team, led by Jerry, had been very active this year of making connections in more than 20 countries, and we have attended 30 key events to show the possibilities with our Planet data. And some of our events are visited here on the pictures, like we went to the Africa Climate Summit in Kenya, the Digital Innovation Conference in Zambia, and the Space in Africa event in Ivory Coast. So next slides. Planet is founded in 2010 by a team of NASA scientists, and it took them 4 years to launch our first satellite and almost 7 years to complete the full constellation of Planet Doves. In 2021, Planet became a public benefit company, and since then we have acquired 3 companies to expand our offering. First of all, we have Wandersat. That is a Dutch company that is using public data sources, plus an extensive scientific knowledge to create unique data sets for soil water content, land surface temperature, and biomass proxy. And these data sets are used by large agricultural players like BASF and Bayer, but also reinsurers like Swiss Re. Then secondly, we have Salo Science. This is a San Francisco-based startup that is very experienced in measuring forest carbon. And we have launched the global 30-meter resolution product this month, and we will launch the 3-meter global product in June next year. This data set is used by many national parks, governments, but also carbon rating agencies. And then finally, Synergize, that we have acquired very recently, including the platform Sentinel Hub. They are based in Slovenia and have developed tools to simplify working with large volumes of geospatial data, and are also very well known in Europe for working with a common agricultural policy within the European Union. Our planet's mission has been unchanged since its foundation. We are imaging the world on a daily basis to make change visible, accessible, and actionable. We do that currently with 2 main satellite constellations. So we're starting our video now, and the first constellation are our 180 Dove satellites, and they are scanning the Earth on a daily basis with a resolution of 3-meter and 8 spectral bands. These are often used to monitor large areas. And then to complement, we have 21 task-based SkySat satellites with a resolution of 50 centimeter and 5 spectral bands. And these images are often used for a detailed view over a site or asset. And Planet is also working consistently on future constellation. We expect to launch a technical demo of Tanager next year. This is a hyperspectral satellite with a resolution of 30-meter and 400 spectral bands. This data can be used to measure methane, CO2, and a wide range of other spectral signatures. And last week, we have launched our first Pelican satellite with SpaceX, which will be the successor of our SkySat constellation. We are planning to launch 30 satellites with a resolution of 30 centimeter and 8 spectral bands. We have created a broad range of solutions and subscriptions to support many industries and use cases. We have a monitoring and tasking bundles to view and download data over areas of interest around the world. We also offer seamless monthly and quarterly mosaics, which have minimal effect of cloud, haze, and other variables. And then we have analytic feeds that can be used for road, building, plane, and vessel detection. And finally, our planetary variables that cover the solutions from our acquisitions, as mentioned before. And Gerald will show some examples in the use cases from these. And then partners. As Planet, we sell directly, but our partners are equally important. So depending on industry and region, we work with different types of partners. So we have resellers who are providing raw images to end users. We have solution providers who integrate Planet data within their derivative products. We work with platform partners who sell imaging on a marketplace structure. And finally, we have system integrators who work closely with end user to ensure seamless integration of several components. And Planet is active in many industries, from agriculture and insurance to emergency management and mapping. And my colleague Gerald will run through some interesting use cases and examples from our clients in Africa. So now I hand over to Gerald.
Thank you very much, Annette. Thank you for the generous introduction, and thank you very much for the Space in Africa team. As you know, previously introduced, my name is Gerald Diegon, and it's a pleasure to be here to join you and to share and engage, and discuss how we can utilize Earth observation. And I'd first like to start by, asking ourselves how Earth observation is critical for some of the world's most pressing problems. And for us, of course, we have to just think about how data can be used across all of the SDGs, and it has been tested that 14 out of the 17 Sustainable Development Goals can be measured or supported by Earth observation. So the work that people in this industry do are very important, and unfortunately, according to UNEP, just about 42% of SDG indicators had sufficient data to assess the progress of these indicators. So just about 7 years to go till 2030, we need to find ways of accelerating ways in which we monitor, we assess risks, and look at policy and interventions using Earth observation among other interventions and measurements of indicators. So over the next 20 minutes or so, we'll be talking about how we can utilize Earth observation across various industries, from agriculture, urban planning, tax and permitting support, right all the way up to energy and water quality monitoring. And of course, some of these use cases, we had so much in mind, but we just had to select a few based on the feedback that we got from the attendees, from your feedback, from your questions, from your key questions and areas of interest. But for those whom we will not be able to cover your interest, we'll be happy to do so during the Q&A, which we have left it to be the last session or the last part of this webinar. To start off, agriculture, as we all know, is the backbone of several African countries. In some countries, it accounts for up to 70% of the gross domestic product. So of all the key areas that the planet is active in, agriculture is closest to our heart. And if you look at it from a point of the entire value chain, we see how Earth observation is critical from early season operations right to crop management, harvesting, and planning. In the next few slides, I'll also be talking about in detail how relevant this is by virtue of what we provide in terms of the resolution we provide, the frequency of the data that we provide, to be able to support the entire monitoring frequently. If you look at this example on your screen from Orange River in South Africa, you see how we are able to monitor within a span of in weekly monitoring. You're able to see how we're able to detect in-field anomalies timely and accurately, and combine up-to-date field imagery with on-the-ground data, so that you're able to inform critical decisions at key stages of the crop development cycle, and you're able to intervene before it's too late. One other area that's very critical, and we saw from the feedback we got from your questions, is crop classification. I just want to reiterate how cadence plays an important role in machine learning data and training, the various models using, of course, the spectral bands, and also, of course, the vegetation indices that you want to be able to develop crop type maps, using the data sets that we provide. Of course, if you want to highlight, 3 important areas among the many others, you want to see how irrigation monitoring has benefited from our data sets in Egypt. And you can see how from the images that, we were able to detect things like sprinkler issues, and you're able to pick up the stress within the irrigation fields, and be able to find out what the problem is before it becomes costly. And also, if you want to look at pesticide management, precision agriculture, of course, benefits phenomenally from Earth observation data, especially at a larger scale, where you do want to utilize maybe low or smaller intervention. So Planet is able to provide up-to-date information to better understand in-field variability, so that you're able to apply, whether it's pesticides, or to find out what is responsible for crop stress. We all know, or as you may know, chlorophyll is one of the most apparent, indicator of crop vigor. And with this, of course, because of the spectral resolution that we have, we are able to map chlorophyll content in crops. And with our high cadence, we're able to provide crop health monitoring across the season that enables better informed application of variable rate application of fertilizer and other farm inputs. With this, of course, we're also able to move to our next session, which is humanitarian impact. I ask that we maybe reserve questions to the last, to the last session. So for humanitarian impact, I'll just talk about 3 important issues around population, health, and migration. To start, of course, I want to give you an example of Niger, where you can look at images from back in 2012 and look at the difference in 2023. So with the naked eye, the changes are apparent. But other than the datasets that we provide, as Annette mentioned, we also provide analytic feeds. That means we do not expect maybe users to look at a large area and try and pick out the changes or new buildings that come up. So Planet has taken the extra step to add value in the space, the space value the pyramid to kind of provide additional value to the datasets, and we're able to provide these through various channels, be it APIs to your environment of choice, or using our Planet Explorer. So if you can see the two examples previously shown, and also now you can see how we can pick up the new buildings which are blue, and this is able to help you inform where you need to be setting up new infrastructure, new power transformers, new utilities, new networking, and even social amenities as the population is growing, and as the city is growing, you're able to tell the trend and detect or know where it's growing towards. So generally speaking, data is very relevant throughout the national statistical systems, and to be able to baseline and provide the foundation in which countries understand and make decisions, to be able to know where people are living, to also know what is happening and which trends are we observing. And climate being an important issue of this era, we are looking at, are there climate-induced migration, and where are people migrating to because of climate? For example, pastoralists, are they moving to in search of new pasture as a result of climate-induced migration? And how that affects aspects like food security. And over and above, we look at also things like environmental causes of disease burdens. For example, throughout Eastern Africa right now, we are experiencing higher than normal rainfall. Therefore, that is causing flooding, and with flooding, you start expecting waterborne diseases. And therefore, what interventions would you want to put in place? And that's the kind of foundation that we're talking about when you want to leverage other observation data. And in the same spirit, let me also give you an example of how we look at drought and food security. As Representative mentioned, we look at soil moisture, for example, as one of our planetary variables. We're able to look at soil moisture trends over the years. And just to give you an example, in Somalia, you can see from 2021 and 2022, and you are able to look at the trends, and you're able to to find out which are these areas that are expecting water gain and which are these areas that are expecting water losses. And this is an area called Jawar. This is one of the most productive areas in Somalia, and this is also an important input to aspects of drought insurance, as an example. And let me also give you an example of index-based insurance that is using NDVI. This is an example in Kenya that for the Kenya Livestock Insurance Program, where satellite data is converted into spatially aggregated and seasonally averaged indices. And this helps insurance companies to calculate payouts when certain thresholds are exceeded or surpassed. This is also an important and new way of looking how index-based insurance and social protection schemes for pastoralists can be better supported from a scientific basis and from a more acceptable and transparent measure. Let me also talk about aspects of tax permitting. This is generally in the areas of development control, and is leveraging our automated change detection at a global scale. And this is able to show important aspects of property tax control, permit compliance and enforcement, as well as illegal road detection, or road detection for that matter, any changes in the structure. And to start, let me give an example a little bit far from home about how Poland has been able to utilize Planet data with the support of our partner, Search Revolution. And we see how the analysis in inconsistencies of their cadastre has led to increase in revenue, has led to reduce in inconsistencies, and of course has identified incorrect taxation with more than 50% accuracy, which is quite significant for those who have had experience in this kind of work. And of course, as a preventive measure, citizens are now voluntarily submitting information and supporting the government in complying with the tax systems. And if you just ask yourself, how is this applied? So in practice, this is how it looks like from a point of looking at the cadastre information and leveraging planet data to look at the structures and changes over time. And now, lastly, being able to identify inconsistencies in terms of the registered tax-paying properties and those who are not paying the taxes, and therefore the alerts are able to be created from this and mobilize now more revenue. And this is a successful example that has led to a great increase. And these are some of the ways that we see governments can benefit from Earth observation data. In the same spirit, we're able to move to Algeria and Niger along the border, where planet data was used to identify, a new road using our road detection analytics. And this is important. By using our high temporal resolution, we're able to analysts to monitor key strategic locations and identify anomalies over large and expansive areas and very big countries and areas of interest. If you want to ask yourself, how it works in practice, you can see, from 2021 in November, and a month later, and another month later, you're able to see, weekly, and you're able to see how the road is growing, and you're able to pick up these changes at a pixel level. And this is very relevant and strategic to road agencies or authorities who are responsible for regulating and controlling this kind of activities. Thank you. Also to talk about mining. Mining, of course, is a very important resource. As many African countries are endowed with a lot of mineral resources, and this is a key example. So I wouldn't want to talk about a lot of aspects in mining. I just want to focus on two key topics. The first one being artisanal mining, and for this, I'd like to take you to Ghana and look at this forest in terms of how artisanal mining has affected the forest. And of course, when you see how this was, for example, in 12th March 2019, and looking at it in 2020, August, you see the difference. And one key issue that you might want to pick here is how all these activities are, happening along the river. So you can imagine, the effect, the pollution to water in terms of mercury pollution to water, and also the soil in the area, and not to mention the very apparent deforestation. And even if you go, about March again, you're able to see much at a higher scale in terms of how it's happening. So this is just an example of how we're able to pick up these changes and monitor deforestation at a very large scale, and be able to inform tax authorities so that they can put in or put the right interventions and regulate some of these highly lucrative industries. And as a second example, I want to show you how, the mining, again, same scenario, but now from a disaster management point of view, just to show you some examples about a tailing pond failure in South Africa, and how planet data was utilized to monitor and to kind of show the affected areas. So if you see this, before the failure, and after, and you see how the populations, and the communities, the houses living near the pond were affected. And if you want to zoom in now using the sky satellite, you're able to see exact number of houses that are affected. So this is one of those examples that you could also utilize in terms of the disaster management. And as much as we didn't pick it as a topic, but you're able to see how you can utilize the data to be able to inform some of these issues. On to our second last topic, that is around energy and utilities, and how we are able to help you monitor your infrastructure. I'm talking about aspects of the right of way, especially monitoring linear infrastructure, which can be quite expansive, and also vegetation encroachment, and being able to also monitor your assets. And as we speak about this, I'd still again like to reiterate the importance of high cadence data, because this is what can enable powering machine learning tools and automation of monitoring solutions, so that you're able to gain unmatched real world business intelligence capabilities and be able to map your infrastructure, your right of way, and oversee the changes on the ground and anticipate risk in a more timely manner. And for this, I'll be showing you how power line monitoring can be done in a more automated manner using our data, because of how our 3-meter data is sensitive to spectral change. So for this, we're able to pick up some of this vegetation growth, and with this, you're able to intervene before vegetation encroaches or affects your power line. And in some countries, of course, this is a big issue, especially or very forested nations. And of course, you're able to pick up the exact affected areas, and you're able to put in the right interventions. And the same spirit of right of way, to give you also another example of encroachment on pipelines, which could lead to significant risks. We're able to pick up some of these changes, including new buildings that come near the pipeline that could easily affect the integrity of your pipeline. So depending on the interest, of course, as in this example in Northern Egypt, you're able to see how you can choose the buffer zone that you want to monitor the changes in and automate these kinds of analytics. And as the last example, I want to just also take you to 2021 March in Indonesia, where there was a disaster, and an oil refinery caught fire early in the morning. And if you want to zoom in and see some of these pictures, you're able to see the detail in terms of the day of the unfortunate incident. And again, if you want to see again the post scenario, you can also see the impact of this fire incident and how it has affected the neighboring communities. And this could also inform things like insurance premiums. It could inform interventions, and it could also inform the right recovery mechanisms for the government. Allow me to talk about the last topic so that we move to the Q&A. Water monitoring, of course, being an important concern, especially access to fresh and clean and safe drinking water being an important concern for many governments. Let me just talk about how you can monitor water levels and also quality and stability of this water, and also monitor some of these important issues like algae. And to start by showing you an example of how we look at surface area calculations based on our PlanetScope data, and it strongly correlates with the reservoirs changing elevation, aligning with the reported decrease in volume during the late spring and summer months. And if you want to look at this is an example in the United States. It's an important indicator in terms of how you're able to estimate how much water you have left, or how much water you have in your reservoir. And with this, again, you're able to see at a larger scale. And for this example, you're seeing how water is increasing in the Lake of Galilee. On to the second last example of algal bloom detection. And it is a common phenomenon, especially in warm environments where we have a lot of eutrophication because of release of and discharge of effluents and fertilizers, nitrogenous fertilizers to water bodies by farms and other forms of pollution that has resulted in increase in algae. So Planet data is very relevant in terms of detecting algae and being able to analyze, like the prevalence and the sources. And this, while is important to pinpoint the areas and to show us where all this is happening, there is also another important area of application, and not just in monitoring, maybe coastal seas and more efficient planning for cleanups. If you want to see, for example, in Botswana, where microscopic algae, this is cyanobacteria, was responsible for hundreds of elephants. And this is also an unfortunate and also monitorable and avoidable incident, where you can use some of these other observation data sets to monitor the increase in algae in water ponds like these ones, and be able to close them out, or to clean them out, so that our wildlife enjoy clean drinking water. that being the last example, I want to thank you for listening to me and for your time so that we can move to the Q&A. So allow me to revert the mic back to Annette. Thank you so much.
Yeah, thank you, Gerald. We got a few questions that we can start answering, and maybe you want to help me as well, with some of the questions. We just got a question a minute ago where it's being asked, like, could you provide examples for finance and business intelligence use cases? We see more interest coming up from this market, and it's mainly about risk assessment. Also, environmental changes are of big interest of the finance and banking industry. So we see more demand on sort of general situational awareness and estimation of risk coming from that market. Also from business intelligence, our data is often a component. Of course, other data is added to it, to several like systems to create analytics over certain areas. So it's quite common. And also Gerald gave a couple of examples from the finance and banking industry, but there are of course a lot more. So please do not hesitate to reach out if you want more information about that. Then I got a question, and maybe you want to answer that, Gerald, because it came in quite early in the webinar. So maybe this answer is partially questioned already, but the question is like, what do you see as the main use case in Africa, or where a lot of demand is coming from?
Thank you so much. And just to also complement, interestingly, finance and business intelligence is a very broad topic, because some of the aspects of business intelligence and finance relates to traceability of raw materials and goods. And that's another area that Planet, can come in strongly to support, especially in light of the new regulations by the European Union on deforestation. That was one of the questions that was asked by one of the delegates or attendees. So just to also add to that, and some of the important use cases that I've seen, especially as a trend, is the one that is monitoring, urban and regional development. That's an important one. I've also seen how disaster management is a growing concern, and right now, as we are having conversations around climate change and climate finance, and having the debate between the global north and global south, I see how some of the other observation data sets could be relevant in supporting and informing some of these debates and dialogue. Thank you.
Yeah, so there we have a next question. If we have any special offering for education and research, and that answer is actually we do. We have special bundles available for universities and also research institutions who use satellite data within their programs. So you can always reach out to us to understand more about those. Then a next question, maybe Gerald, you want to answer this one. How do we capture a planet scope? How does that work?
Thank you. I think from the video, you are able to see how we do it, and basically we have like doves satellites. They are about the size of a big bread, depending on your where you're brought up. So yeah, they're quite big. It's about less than a meter anyway. But generally, we use these data sets, and of course, we launch them just about 350, 400 kilometers from Earth, and that's how now we are able to have like hundreds of them, and they're able to take images on a near daily basis. And of course, these ones now they're able to send the same images to our ground stations, where we process them, and then we calibrate them, and we now push them into Planet Explorer. That's our main dissemination platform, where our users and customers and partners are able to utilize this either in our platform or in their platform of choice if they have the right APIs and connections.
Thank you, Gerald. Then we got a question. Can you talk more about how you partner with local players? So in my sheet about partners, I gave some examples of the different partners we work with. So it depends a little bit about how they work. You know, as mentioned, we have resellers who are just reselling images. We have partners who are really providing solutions and have Planet as one of their components. If you are interested to read more, we have a separate chapter on our website where you can read more about how you could cooperate with Planet, and you can also fill in a form to get in touch with us, you know, to work with us as a partner. Hopefully that answered the question, but let me know if you want to understand more in the Q&A. Then the next question was if we also provide radar data via our platform. We don't do that via our Planet portal, but since our acquisition of Sentinel Hub, we can provide like radar, public radar data via the Sentinel Hub platform. So that's available via them. Then there was also a question, Gerald, maybe you want to take this again, about like how a task works. Like Sky said, high resolution task, how does that work in reality? Gerald, you're on mute, sorry.
Oh, sorry, thank you. So we have an interesting way of how we handle tasks. So as mentioned, we have two main constellations. The first one being a PlanetScope. So for this one, we have a continental or global coverage, if you like. And we use this basically to monitor changes, you know, any kind of change. And now we consider SkySats to be our kind of zoom-in satellites if you're interested in a higher resolution image of a particular area. So for this, we have a dashboard or a portal where you can you can just go in and utilize your maybe tasking credits or your quotas. You can order that image, and you basically can get it. So we have like three types of tasking. You have the low interest or assured tasking, whereby depending on the type of task you require on your use case, we are able to prioritize your need as Planet based on the kind of engagement that we have together. Now there are certain things, of course, that can be as a challenge to this kind of a scenario, depending, of course, for example, the time that we take to capture that image. Luckily, we have more than 20 of those satellites. That means we have a higher chance of getting that image for you at the earliest possibility. Sometimes even in the same day. And this, of course, gives us a higher advantage of being able to get you the data that you require.
Thank you, Gerald. Then we have a question about how customers can access our Planet data. So we have a couple of options for that. We have our own Planet Explorer user interface. We also have APIs available, and we also have plugins to a couple of different software types. So we have a plugin to Google Earth, we have a plugin to Esri software, and also to QGIS. So there are several options to access our data. Then there was another question about from what open source data the soil moisture data set is compiled. And that is actually a mix of public data from NASA, JAXA, and Sentinel Hub. That's a blend of data. Then there is a question, let me see. Oh yeah, that's also in our chat box. Like, what other inputs from the ground are required to make satellite information accurate? Are they provided by the users too? That actually happens quite often, that data from the end customers is combined with satellite data to get more data out of it. We also work a lot with partners in this case, who are really able to build models on ground data, satellite data, other data from agricultural systems, to combine these all into a solution. So that happens in different ways depending on the use case. Then there is maybe one for you, Gerald. Like, do you have an example for livestock agriculture? Do we see that use case in Africa?
Thank you, Annette. And that's a very great question. For livestock agriculture, we are looking at it from a point of from a two-point perspective. The first one is in how we can monitor rangelands, especially in arid and semi-arid lands. If you're coming from a not so, vegetative or forested area, where we can help you quantify the vegetation, content. We have things like crop biomass, where we can help you analyze above ground crop biomass. And for this, we are able to help you to quantify how much you have in terms of your rangeland vegetation. And the second aspect is now in being able to, of course, monitor things like water quality, water ponds, and those kinds of things, and also being able now to even support the government or even other players to come up with the livestock insurance. Livestock insurance is one of the trending topics right now that we see a lot of people having interest, not just from governments, but also from developing development partners. For example, our case with ZEPRI is the one successful case that has attracted interest from government of Kenya, Somalia, as well as Ethiopia, if I'm not wrong, Annette. Thank you.
I think that is our last question in the Q&A. So are there any final questions? So maybe also in the meantime, while we are waiting, if a final question is coming in, are there any questions from the Space in Africa team, maybe?
Thank you very much for your presentation, Annette and Gerald. It's very well detailed, and apart from just talking about the fundamentals and the ways how you can use EU data, you are also able to show some examples, use cases to actually see what is going on the ground. So one other area that I'd like to talk about is when Gerald was presenting, he showed us some slides about how EU data is applicable in mining operation. So I just wanted to maybe a little bit break that down a little bit into the different aspects of mining operation. He showed us something about reclamation, but he showed us how EU data is used to track changes during tailing operation, which is like the tail end of mining operation. But do you guys have specific use cases for how EU data is used across all mining operation, from prospecting to production down to reclamation?
Gerald, do you want to take that?
Thank you, Mustafa. Now our data sets are very useful, and especially the new satellites that we'll be having that will help us understand, chemical properties of materials even better. Right now, the requirements for, analyzing specific, mineral ores, might be quite limited, but we provide and complement with other things, especially now in terms of monitoring those kinds of things. But I understand that the deformations, monitoring of specific, indices of minerals are in a very unique band, electromagnetic spectrum. This makes it quite difficult for, any satellite provider to tell right now. So that's why you don't see a lot of, exploration being discussed from a satellite point of view.
All right, thank you.
But yeah.
Another trend that we've seen also is how, governments are trying to see how they can utilize EU data to monitor their borders, for national security and other associated tasks. So do you have any use case for that you can share with us?
Go ahead,
absolutely.
It's your expertise.
Yeah. So our data has been very useful in monitoring border, not just border conflicts, but if you've been following the news, our data has been very relevant in monitoring the situation in Gaza. Our data sets have been used in monitoring various international borders, even in the Ukraine situation, and because of our cadence, we provide a higher value. And of course, our tasking satellites, again, are able to kind of provide more value in terms of intra-daily revisit. So So, for example, once we capture, using our 3-meter data, changes in terms of movements and coming up with new structures, we're able to pinpoint, areas of interest or features of interest for now the government to send in, or security, agencies to send in, on ground troops to go and monitor the situation.
All right, thank you. The last one I have is regarding, healthcare. So do you also have use cases around that? I mean, there are different areas to, utilizing EU data for, sustainable healthcare in Africa. So do you have any use case to any area in healthcare?
Not directly, but we've seen how the Kenya Malaria Control Division has leveraged other observation data to monitor and being able to understand malaria prevalence and tied to like coming up of ponds, especially during the rainy season. And I've seen this as a successful case because some of these data sets have been utilized to basically advise and being able to warn members of the public. And I've seen the government tying this to even things like mosquito nets distribution as an intervention to stop spread of malaria. So some of these, including other waterborne diseases, are some of the areas that governments can look into, especially during flooding situations. Annette, do you want to?
Sorry, to enhance on flooding, you mean?
Yeah.
Yeah, so we get more and more requests from flooding. It depends a bit on the use case that customers are looking for. But with our satellite data, we are quite able to especially see the before and after scenario. And that's also quite requested from the finance and banking industry. So they wanted to understand, like, what is the impacted area? With our optical data, it is not possible to measure depth of a flood, then you need other type of data sources. But optical data can give a really good sort of understanding, like what scale the flooding is going and like what areas are impacted. And because we are scanning the Earth on a daily basis, of course, depending on the weather conditions, but we would always have like a before image, and then as soon as possible after the flooding event. So that can give quite a good view of what's going on in the area. So this is used quite often.
Okay, I just got another question from the team now, and this is regarding tourism. I mean, the trend now for most African countries, is to find a way to improve their tourism aspect so that they can use that to generate more revenue for their respective nations. So do you have any solution that is targeted towards tourism, monitoring wildlife, monitoring their dispersion and all of that? Do you have anything regarding that?
Thank you. By the way, unlike some advanced and very mature tourism destinations like Dubai, for example, Africa is also coming up strongly, and one of the driving forces is wildlife and natural resources. And in this aspect, the most important thing, in my view, is to monitor the habitats and ensure their health and their sustainable utilization of these conditions. And therefore, just like the example we gave about the Botswana wildlife and how it can be, how our data can be utilized to monitor and avert some of these preventable incidences. Our data can also be used, especially in monitoring forests and other related ecosystems, in monitoring grasslands. And if you see, for example, the Northern Sahara has experienced like the worst drought in 40 years, and this also led to death in thousands of wild animals because of lack of water and vegetation. As an example, Kenya had to think and look into using Earth observation data to utilize, to kind of understand where vegetation is low, and using their data sets and their baseline information of where they know and how much wildlife they know exists in specific places, they're able to calculate at least the rangeland carrying stock. And some of these are now some of the examples that we see as potential or currently being utilized use cases.
Is that clear, Mustafa? Because I also see like a final question in the chat, and that's about like what type of training Planet can offer. First of all, we have quite a good section on our website, and I also sent the link to the person who asked this question, but it's called Planet University, and it can be found on the bottom of our website. And that gives a really nice overview of training courses that are available around generally working with Earth observation data, but also specifically about our data. So that's a good starting point. We also have our own professional services department who could offer all sorts of training courses depending on the final use case and need. So that could be is an option as well.
And Annette, I also saw something at the end.
Yeah, sure.
Yeah, I just also saw another question about maximizing, helping users maximizing and getting the most out of the data. And just to also complement what you just said, with how Planet has a dedicated customer success management programs that help you leverage this data. And also we have a very robust partner network that we call them. They help us execute the last mile of some of the solutions and pressing problems that we see our customers needing. So we leverage also our partner community to provide, very highly technical, solutions that rely on our data. Thank you so much.
Yeah, so Mustafa, I think this was the last question from the audience.
All right, thank you very much. And with that last question, that brings us to the end of today's webinar. So once again, thank you very much to all the participants for joining in. And thank you, Annette and Gerald, for sharing those critical insights with us. We appreciate it. So if you have any additional questions, this is to the attendees. If you have any additional questions that you'd like to ask them, please feel free to connect with them on any social media platform, LinkedIn and all sorts. Connect with them and direct your questions to them, and they will be more than welcome to answer your questions. So one last thing before we end the webinar, I want to just take a minute to tell you about the 2024 New Space Conference that will be happening in Angola. So for those of us that are aware, this is the third edition of the conference. The first one was held in Kenya, the second one in Abidjan, Ivory Coast, and the third one will be in Angola in April 2024. So if you would like more information about that, you can just log on to our website and see more information regarding that particular event. So thank you very much, everyone, for joining in. Until next time, we look forward to seeing you. Bye, everyone.
Thank you. Bye-bye.